Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents problem number 23. If you want to look at these exams, go to nyscdregents.org, click on the appropriate tabs, and all the exams are available right there. Here's the problem. Based on the graph below, which expression is a possible factorization of p of x? And I do look at the graph before I start the problem. I look at the graph, it goes up here, goes through -3, goes up, back down, has a positive y-intercept. Okay, I don't process it too much more than this. Goes through 2, goes down, back up, goes through 4, and then kind of seems to blow up. I don't analyze it much more than that. I don't need to fully understand what's going on here. But here's the factorization. It's actually plus 3, x minus 2, x minus 4, x minus 3, x plus 2, x plus 4. Okay, x plus 3, x minus 5, x minus 2, x minus 4, or x minus 3, x plus 5, x plus 2, x plus 4. Ooh, a lot of factorizations. Okay, now here's what I do know. Even if I don't remember the basic theorems, I do know that p of -3 equals 0. Equals 0. I know that p of 2 equals 0. And I know that p of 4 equals 0. Okay, so all of these have to be true, and I also know where p of x is positive. P of x is greater than 0 here, p of x is greater than 0 here, p of x is less than 0 here, and p of x is less than 0 here. So here's the fact. I mean, if you have no clue how to do this question, you could still take test points. Plug in -3, plug in 2, plug in 4. All of those have to give you 0 for all the choices, and there's going to be only one choice that gives you that as the answer, and it's going to be choice 1. Did I lie? I did lie. There's going to be choice 1 or choice 3. So then you'd have to consider between these two. And you know for a fact after you test those numbers that it's not going to be those. But then you could test, let's say, plug in 0. Okay? And you find that you get a positive number, whereas this one happens to give you a negative number at x equals 0. So that happened to be a lucky choice for a test point. This is not the answer. So that's choice 1 is the answer. That's just by taking test points there. Okay? So I just said p of 0. Whatever it happens to be is greater than 0 because it's above the x-axis. That's all I did. That's without even knowing how to do the problem the way they expect us to do it in quotation marks. Okay? We're done. We're all set. But let me make sure I tell you how to do it anyway. There's a theorem. Okay? Theorem. Okay? Let's say p of a equals 0 if and only if x minus a is a factor of p of x. It's a fact. So that's the theorem. So I know that -3 is a root, I know that 2 is a root, and I know that 4 is a root. Okay, which means that p of x has factors. Let's see, x minus the root. This is a -3. So x minus -3, which equals x plus 3. Also x minus the second root 2, and also x minus the third root is 4. And only choice 1 and choice 3 have those factors: x plus 3, x minus 2, and x minus 4. So we do have to eliminate this one for some reason. But here's the reason we know that this is not the answer. It's the same reason. It's p of a equals 0 if and only if x minus a is a factor of p of x. But this is equal to 0. This equals 0 if x equals 5. Which means that 5 is a root of this polynomial. But look at 5. And look at p of x. P of x is greater than 0. P of 5 is greater than 0. So 5 is not a root of this polynomial. So that's not the answer. So it has to be choice 1. Okay, that's the way they expect you to do it, but you could use any way that you want. We just used 2 different ways to do it. So method 1 was test points, and method 2 was this theorem. Okay? So let's do an example. This is a problem created by us. Based on the graph below, this graph should look familiar. Which of the following could be true about P of x? And there's a few statements there. Highly recommend that you pause the video right now. Try the problem on your own, and when you're done, just press play and see if we did it the same way. If you like this video, hit the like button, subscribe, let your school friends know that these videos are available. We're doing tons of videos, hundreds of videos. So let them know that these are available. And definitely thanks for watching. So we're gonna continue with the problem now. It's a cubic function with a positive leading coefficient. So which could be true about P of x. So this is what I do know about cubics. Cubics tend to do this kind of squiggle. If they have a positive leading coefficient, they blow up in the positive direction and blow up in the negative direction on the negative side. So it could be a cubic function with a positive leading coefficient. That's could be true. So now this one, it's a quartic function with a repeating root. So this one looks good. Number 2, quartic function with a repeating root. A quartic function is a degree 4 polynomial. Okay, 4 polynomial. Just like a cubic is degree 3, just like a quadratic is degree 2, a quintic is degree 5, etc. And a quartic function is a degree 4 polynomial, and it happens to have there's a fundamental theorem of algebra, a big theorem in the history of math that says an nth degree polynomial. So this is a theorem. An nth degree polynomial has at most n real roots. And in fact, it has, for the people who happen to be not watching this for Algebra 1, but are watching it for like Algebra 2, for example, it has exactly n complex roots. And the complex roots include the real roots, because real numbers are complex. So that's for the people who are taking Algebra 2. If you're taking Algebra 1, don't worry about complex numbers for now. But it has at most n real roots. And now this is the thing. This polynomial has a root at -3, but the function goes right through -3. And without pause, doesn't flatten out there. So this is a degree 1 root. This is also a degree 1 root because the function passes right through at an angle. And this is a degree 1 root because the function passes right through at an angle. So if this polynomial has another root, it's not any of these. The second thing is that a quartic polynomial can have at most 3 wiggles. It can look at most like that. So it could have at most roots like that, or maybe something like this, and maybe it has roots like that, or maybe it has a repeating root, but that's it. This polynomial might turn up later, but it does not have a repeating root, so that's not it. Okay, this one, it has at most 2 real zeros. Well, I'm looking at 3 of them right here, -3, 2, and 4. So it has, nope, has 3. At least. And then one of its factors is x minus 3. And we learned from the previous problems, this is if and only if P of 3 equals 0. Because 3 minus 3 equals 0. If x minus 3 is a factor, then 3 minus 3 is a factor of P of 3. But P of 3 is less than 0. P of 3 is less than 0, is not equal to 0. Okay, so this is not the answer. So in fact, this is the correct answer. All right, I hope you got that. Listen, keep working at it. I know you can do it. Thanks for watching. Click the like button, subscribe, and stay tuned for the next video starting right now.